Welcome back, focused learners, to another Engineering Explainer. Today, we're tackling what is, honestly, the most lied about number in every single tender: CCTV storage calculation. We're going to completely strip away the marketing fluff and focus strictly on the honest numbers. Let's make sure your next project calculation is absolutely bulletproof. Look, we face a massive critical failure mode in our industry. On one hand, you've got engineers constantly under-speccing storage just to blindly hit some budget target. Obviously, that's a total disaster waiting to happen. But then, on the flip side, vendors are over-speccing just to dishonestly inflate the bill of quantities. Both of these approaches are fundamentally wrong, and honestly, both are going to end up costing you the project, your reputation, or probably both. We really need a better way to do this. The bandwidth first method. So let's dive into the definitive solution here. You really have to stop thinking in massive blocks of terabytes right out of the gate and start thinking purely in bandwidth. I want you to anchor your entire mental model to this single solitary number, 2 megabits per second. What is this exactly? Well, this is the reliable baseline average bitrate for a standard 4 megapixel camera running at 30 frames per second using the H.265 Plus codec with intelligent streaming, looking at a normal, everyday scene. That 2 Mbps right there, that's the absolute bedrock you start with. So, how do we actually build this into concrete capacity? It's a strict, chronological, mathematical flow. Step 1. You take your bitrate in megabits per second and divide it by 8. That simply converts it into megabytes per second. Step 2. Multiply that by 86,400. Why? Because there are exactly 86,400 seconds in a day. That gives you your daily megabytes. And finally, step 3, multiply that daily figure by your required retention days. This is the strict flow that turns theoretical bandwidth into real, actual storage demands. The 800-camera hotel example. Let's take this whole concept out of the theoretical realm. We're going to apply this pure math to a real-world scenario that you typically see in a standard 5-star hotel tender. All right, let's walk through these metrics together. We're taking that 4 megapixel camera at our 2 Mbps baseline, and let's just assume a standard 30-day retention period. For a single camera, the math works out like this. 2 divided by 8 is 0.25 megabytes per second. Multiply that by 86,400 and you get 21.6 gigabytes per day. Multiply by 30 days and boom, you get exactly 648 gigabytes per camera per month. Now scale that whole thing up to the 800 cameras typical of a 5-star hotel and you reach a very realistic 518 terabytes of net storage. Notice I said net storage. We are definitely going to get to the gross numbers in a minute, but this just proves how cleanly that baseline scales up. Variables that shift bitrate. Now, in engineering, garbage in means garbage out, right? We've got to account for the physical inputs that can drastically shift that 2 Mbps baseline. Let's look at those variables. Okay, let's look at the major impacts here, starting with frame rate. 30 frames per second is usually the default, but if you drop to 15 frames per second for storage-only cameras, like those pointing down completely empty guest room corridors, you instantly cut your bitrate by about 30%. Then look at the codec. If you accidentally leave the system on H.264, it requires roughly double the bandwidth of H.265 Plus at the exact same image quality. Always specify H.265 Plus as the default above 100 cameras. And finally, scene complexity is just huge. A static parking garage at night that uses just 1/3 of the bandwidth of a busy, chaotic hotel lobby. You absolutely have to match your profile to the physical scene. Let's fire through some other crucial inputs. Video content analysis, or VCA, adds about 150 kilobits per second per camera just for the metadata alone. You really have to plan for this if the client wants forensic search capabilities. Audio, that adds another 100 kilobits per second per channel, so specify clearly if they actually need it. And then there's the recording mode. A busy lobby on motion-triggered recording might reach 60% of continuous bandwidth, while a quiet perimeter at night might drop to 10%. But hear me loud and clear on this one. Most commercial projects absolutely rely on 24/7 continuous recording for legal safety. Motion-triggered recording creates legal gaps. Really, don't even propose it unless the client formally accepts that massive risk. So, the crucial point here is getting your retention days right. 7 days is your absolute minimum for low-risk commercial sites. 30 days is standard for hospitality. 60 days is often strictly required by spec for sensitive sites, particularly in regions like KSA. And 90 days or more, that's standard for banking and critical infrastructure. Now, let me give you a serious pro tip. Always read clauses 3 or 4 of your project specification. Retention days are almost always buried right there. If you miss this strict discipline, I guarantee your calculation is going to fail. Calculating vital system overheads. Now that we've totally nailed down the net storage, let's step out of the pure math and into the somewhat harsh reality of enterprise system overheads. These are the mechanical realities that turn your perfectly calculated net number into your final massive gross capacity. Server architecture exposes some incredibly counterintuitive mechanics. You absolutely must add 30% headroom. Why? Well, let's take a specific example using Bosch's BVMS, the Video Recording Manager, or VRM, downtime parameter. By default, cameras actually reserve blocks on themselves to keep recording even if the main server goes offline for up to 4 days. For a 2 Mbps camera, that 4-day safety net permanently locks up 86 gigabytes per camera. Across 800 cameras, that is 69 terabytes locked up just for downtime. Then you have the 2-day sanity check parameter, which is basically how often the system recalculates its storage needs. If you set those sanity checks higher than the VRM downtime, the system literally panics. It allocates extra blocks because it can't detect higher bandwidth scenes fast enough. It is totally counterintuitive, but absolutely vital to understand. And then, of course, we have the physical hard drives. The RAID 6 overhead is calculated by taking 2 and dividing it by the total number of drives in the array. So for a 16-drive enterprise array, you lose 12.5% of your storage to redundancy. But if you split that into smaller 8-drive groups, your penalty doubles to 25%. Think about our 800-camera hotel. With that 30% headroom added, our 518 terabyte net jumped to roughly 670 terabytes. But depending purely on how you group your drives, your final gross capacity ranges from about 760 terabytes for the 16-drive array all the way up to a massive 840 terabytes for the 8-drive groups. You really have to pick the array configuration that perfectly matches your bandwidth target. Rules for bulletproof calculations. Okay, let's pull all of this together. We're going to codify everything we've just learned into a strict spreadsheet-based discipline known as the Mohammed-Method. If you want to survive consultant scrutiny, you must adopt these 3 strict, no-nonsense engineering rules for your spreadsheet. Rule 1. Bandwidth first. If you cannot write the bitrate per camera in megabits per second, you honestly have no business calculating storage. Rule 2. Document every single assumption. Have dedicated columns for resolution, frame rate, codec, scene type, and retention days. Basically, if you assume it, you write it down. Every cell must be traceable. Absolutely no magic numbers. And Rule 3, always add 30% headroom for VRM blocks, metadata, and future growth. Never less than 30%. Storage calculation is exactly where junior engineers fail tenders, and where senior engineers win them. So I'll leave you with this provocative question to chew on. Is your next storage cost sheet bulletproof? Now that you understand the honest numbers, it absolutely should be. For our next explainer, we'll tackle another deeply misunderstood topic, why RAID 5 is fundamentally wrong for any project above 100 cameras. Until then, keep learning and keep building.